Good morning, everybody. If you go ahead and give me a green check in chat so I know you're with me. Looks like we're missing a few people, so they might just be logging into the homeroom and then coming in here. So we'll just maybe give a couple seconds for everybody to get their way into the chat room. Looks like a lot of conversation about the midterm happening, which I guess is to be expected. I was generally pretty pleased that everyone showed up. That was amazing to see you guys all there. I was happy to have everyone there, even some faces we haven't seen a lot of. And generally speaking, the marks were pretty good on the midterm. I mean, there was only a few surprises, and everyone seemed to maybe just be really scared when they handed in the test, or they just said, oh, you know, it was okay. So it's kind of good for you guys to experience these sorts of things because you guys are going to have the same sort of experience when it comes to the provincial exam, except there'll be more people in the gym and it'll be a little bit sort of busier and things like that. So it's here so you guys know that it's not this big scary thing to be afraid of. It's just, you know, sit down, write a test. If you're prepared for it, you should be fine. So as long as you're confident going into it that you've done what you can to prepare for that test, then away you go. So in terms of the midterm, maybe I'll just take a second. I have like half people with green checks and half people without. So I have a feeling you all can hear me, just maybe not given that green check mark yet. Ava, the marks for the midterm, sorry, I mentioned that. I sent a message out to everyone in Moodle yesterday. The marks were up yesterday afternoon, and all I did was I added an assignment, and it was just out of 40 because there's 25 multiple choice and then the 5 written at 3 marks each. So if you go to your grades in Moodle, it should show up under, I think I wrote as an assignment called midterm exam, 40 marks. So yeah, if you haven't had a chance to go check that mark, Taylor, yours would have been blank because you did the actual midterm built into the course. So yours would have been exam part A and exam part B for you, a little bit different than everyone else who came to sit down and write it. If you can't find that mark, I can help you find it later. Normally you guys get your test back and then you know, you can review the solutions and things like that you did wrong. So if there's anyone who is interested in what questions they got wrong and wants their test back, we can either arrange a time to meet, or I could possibly scan it and send it to you so you can have a look at the solutions you chose and the correct ones and things like that. So if you do want that to happen, let me know in the next couple of days and we can arrange something so you guys can have a look at your exam and see how you did and where you went wrong and things like that. There you go. The course, where are we at? We are in Unit 4, and I was kind of going real slow at the beginning of Unit 4. We did like the first 4 lessons in Unit 4, and I didn't want to go too far and get into the factoring stuff that we're going to start today, because this is where Unit 4 kind of gets not necessarily tricky, but this is kind of one of the main ideas for Math 10, kind of like one of the really big ideas that you carry forward into Math 11 and 12. So it's important that we have a good understanding of it. I wanted to take my time going through it, and I didn't want you guys to see it before you guys wrote the midterm and worry about it. So, so far what we've done in Unit 4 is essentially just expanding. We've had like a binomial and a binomial, or a binomial and a monomial, or a binomial and a trinomial, and we just multiplied them out using FOIL or the distributive property of multiplication, and that's kind of where we've been so far. We're going to get into factoring today. I promised you guys a look at algebra tiles and maybe some other methods, rectangles and stuff. Give you a look at it, and that's kind of where we're going. So there are 3 sections left. So we have Tuesday, Thursday's class, and then Monday next week will be another class, and then hopefully we can get the Chapter 4 test done Tuesday, Wednesday-ish next week, somewhere in there. And then we got to pick up the pace a little bit and get through Unit 5, 6, 7, and 8. We're halfway down the course. We're looking good in terms of pace. We should have probably about a week to a week and a half at the end of the course for review for the provincial. So everything's looking pretty good where we're at right now. So looking at Unit 4, I'm going to jump into Unit 4, Lesson 5. Polynomials the form x squared plus bx plus c. And this is, what we're going to be covering today. And like I said, this is kind of the meat and potatoes of Math 10. The course does end in January, Taylor. The provincial exams, I think the 3rd or 4th week in January. And Alex, when it says factor completely, we're going to learn about factoring completely today. So it can mean a couple things. So we're going to look at that. So the first one here says use algebra tiles to expand and simplify c plus 5, c plus 3. Now, I'm not a huge fan of algebra tiles, but you guys need to kind of know how to use them. And there's a whole section in the learning guide on algebra tiles, so this should help you do that stuff. So if you've never seen algebra tiles before, there's a couple different things we have. Let's see if I can find a yellow pen. I don't have a yellow pen, so I'm maybe going to use red and blue. So if I have, let's do it over here. If I have a little square, that's just 1. So if I have 2 little squares, that's 1 and another 1. So that's 2. So I can have as many of these little squares as I need, and then each one's worth or has a value of 1. I can do the same thing with negative values. So if I have a negative or a red square, we'll call that -1, and another red square is -1. So that's what we're going to use for 1s. If I have a block like this that's skinny and tall, this is what we're going to use to represent x. So it's kind of like 1 unit wide, same width as these guys, but it's x units long. So in terms of algebra tiles, when we're dealing with all these things, we're almost always talking about area. So if I took length times width, 1 times x, I would end up with an area right here. This algebra tile is 1 by x. Same here. If I have a length by width, it's 1 by 1, so the area is just 1. So that's going to be x. If I draw a red rectangle, this is going to represent -x. And then I can have some other things happen. I can have a box like this. And if this is x units tall and x units wide, what do we think we're going to use to represent that? And same thing goes with if I drew the same thing, but it was red. This is x by x. It's not a very good x there. You do that. So Abby's saying, don't you put a little minus and plus in them? You can. We're going to let the colors kind of represent the signs. So if I have a blue one, that's going to be x by x. So x times x is x squared. And then if I have a red one, same deal, x by x is x squared. Perfect. So those are kind of all of the things you're going to encounter. You're going to encounter 1, -1, x, -x, x squared, and -x squared. So the first thing we have here is c plus 5 and c plus 3. So here's c, or x, doesn't matter what the variable is, and then plus 3. So I'm going to draw 1, 2, 3. So there's c. This is 1, 1, and 1. So that's like c plus 3. And then I'm going to draw the same thing down the side here, but the second term, which is c plus 5. So there's a c. And I'm going to have 1, 2, 3, 4, and 5. So there's c, 1, 1, 1, 1, and 1. So this is c plus 5. So that was the question I'm starting with. C plus 3 and c plus 5. Everything's positive. And all the color blue. I think in the learning guide they use yellow. I don't have a yellow pen for my tablet here and it wouldn't show up really well. So I'm going to use a blue for positive and I'm going to use red for negative. So those are some good contrasting colors. Abby's, that's a great question. The question is, when we're doing them, do we use plus and minus or colors? I mean, it depends what you have. If you are, sitting at home and you have a set of pencil crayons next to you, then use colors. But if you don't have any colors, then, just write pluses and minuses and you should be able to follow your work from there. All right. So what I'm doing is trying to represent multiplication with these algebra tiles. So if I'm multiplying C and C together, what do I get? And things like that. So looking at the picture I've drawn here, I guess you could draw in some like lines here if you wanted. Kind of show where the solution is and where you started with. If you don't have to, but you can. So you want to think about this in terms of area. If I'm going to take this C here and multiply it by this C here, if we had C times C, we would end up with C squared. And representing C squared with the algebra tile works the same way, except when I multiply these two things, I don't end up with something that's just C. I end up with a big one, C squared. I'm just going to write C squared in there because I have room. I probably won't have room for the rest. So same deal here now. I'm going to multiply C by 1. What is C times 1? Well, that's just going to give me C. So I'm going to represent it as a C there. I can do the same thing again, except I'm going to multiply by this guy. I'm going to end up with another C. And again, another C. So I've taken my C and I've multiplied it by everything there. Essentially, what you're doing is you're finding the area of a shape. So we're just going to continue to fill in the shape. If I think about it this way, if I multiply this C by the C, I got the C squared here, so I've done that one. If I multiply this C by 1 down here, I'm going to end up with a C, except my C is going to go the other way. I'm going to do that 5 times. 3, 4, and 5. All right. So that's kind of the beginning of this. If I take it a little bit farther, I've done my C's times the C's, I've done my C's times my 1's. What happens if I take this little 1 here and I multiply it by the 1 there? What do I end up with? Well, I'm just going to end up with a 1. If I did the same thing to the next one, I end up with a 1, and I'm going to continue that all the way down. These should all be the same size. My fine motor skills aren't good enough to allow me to draw boxes that are the same size. Use your imagination. There's 1, and then 1, 1, and 1. All right, so essentially I've made, if you want to think about it, a kind of like a giant rectangle here. Because all I did was I took my length and my width, and I multiplied them together, and I got a rectangle. It just so happens that my length and my width weren't just numbers, they had variables in them. So we have this rectangle here. And that's how all of these multiplication problems are going to work. You're always going to end up with a rectangle to end up with at the end. So when you're filling out your algebra tiles, you just want to fill it up so you've completed your rectangle with the appropriate sort of terms. So now that we've made our rectangle, we need to kind of think about what we have. So what do I have here? Well, I have this C squared. So how many do I have? Looks like I just have the 1 C squared. So all right, I have 1 C squared. How many C's do I have? Well, here's 1 C, there's 2, 3, 4, 5, 6, 7, and 8. So I have 8 C's. And then all of these little guys here just represent 1. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And those are just 1s. So I end up with 15. And that is actually my answer. So we learned how to just expand by way of FOIL last day, or a few days ago I should say, inside, outside, and then the last. We would have ended up at the same spot. So this is just another way to expand binomials. You form a rectangle, you fill out the area of the rectangle, and you just count how many things you have. So that is a way that we can represent these types of things. So hopefully that kind of makes sense. And if it doesn't, I wouldn't lose a lot of sleep over it. If you can just expand binomials with multiplication, then you should be fine. So that was kind of the first one. The second one here is using a rectangle diagram, expand and simplify x minus 4 and x plus 2. So this is another method which you can use to solve these types of questions. So I'm going to start with x and then plus 2, and then I'm going to have x and minus 4. I'm going to make a rectangle in the middle. I think the learning guide refers to this as, I think it is actually the rectangle method it talks about as well. So I'm just going to draw a bit of a rectangle here. Plus 2. There we go. So if your rectangle looks like that, something like that, that would be good. All right, so what I'm going to do is I'm going to take everything here and multiply whatever I have in each square by kind of the opposite square. The area method, thank you, Avery. So what I mean is I have an x here and an x here, so I'm going to have x times x. And x times x is x squared. So I'm going to do the same thing now moving across. I'm going to have my x here, and I'm going to have something over here like plus 2. So I'm going to have x multiplied by positive 2. Well, what does that equal? That is equal to 2x. All right. I have some other stuff here. I have x, and I have minus 4, which is negative 4x, and then I have negative 4 times positive 2, which gives me negative 8. So those are the sort of things multiplied by one another. I've multiplied everything by everything else, and that's kind of where I've ended up with. So I need to think about what I have here now. So I'm just going to take the area, I'm going to take everything that I have. So I have for my first box, x squared. I have for my second box, positive 2x. And it doesn't matter the order you write this. Usually we write them with highest exponent and then working our way down to the lowest exponent. So that is what is in all of my boxes. X squared, 2x, 4x, and 8. I have 4 boxes, 4 terms. Once I get here, I need to say, do I have any like terms? And I see that I have a couple like terms in the middle, my x's. So I just need to take this one step farther. X squared minus 2x minus 8. So what has really happened here? Well, we started with x plus 2, and we multiplied it by x minus 4, and then we ended up with that. So we've done essentially 2 methods now. We've done the algebra tiles, and we've also done the area method. And then the last one here at the bottom is the same thing, multiplying 2 binomials, but we're going to use the distributive property. So let's look at this. Now, you'll remember we've done this a few times, and we called this FOIL. First, outside, inside, and last. So let's do that. We're going to multiply our first term by our first term. I get 8 times 3, which gives me 24. And then I'm going to take my first term times my last, or my outside terms. 8 times negative b is negative 8b. Now, I'm going to switch colors just so you can see where the second 2 terms come from. You don't need to do that. So I'm going to take negative b times negative b times positive 3 is negative 3b, and then my last term is negative b and negative b. Two negatives gives me a positive, and I end up with b squared. Again, when I get to the sort of middle of these questions, I'm always going to look for any like terms. So I'm going to combine those. So 24, 8 and 3 is negative 11b, and then b squared. Now typically I'm going to kind of arrange this from highest to lowest power. So I'd probably write it as b squared minus 11b plus 24, but you can write it the other way. Just this is the way it'll always appear as a solution. All right, so 3 methods. Method number 1, algebra tiles. Method number 2, area. Method number 3, distributive property or FOIL. Maybe in chat, put the number you like the best, 1, 2, or 3. What is kind of the easiest for you to kind of see? Maybe one that you want to do moving forward. It doesn't generally matter which way you do it on a test. All methods are the same. Just throw it in there. What do you like the best? 1, 2, or 3? 2s and 3s. 2s and 3s. 2 and 3. Avery's a fence sitter. She won't decide. That's okay. So it looks like 1, 2, and a couple 3s. I kind of like 2 and 3. I'm not a super visual person, so the algebra tiles just seem like a lot of work to me. But on some questions, algebra tiles can, they can be a good thing. So I'm not saying there's anything wrong with any of the methods. Whatever method you want to do, you can. Just use it. When you get to a test and it's, multiplying binomials and you want to use algebra tiles and draw them out, that's fine. Go ahead and do it that way. So that's kind of the multiplication stuff we've been doing, multiplication of binomials. And you can do the same thing with trinomials. It should work out. So this is kind of where we get to the next sort of stage of all this. This is why we spent so much time multiplying these things together. So what we're going to do now is we're going to kind of do the reverse process. We're going to factor these things. So the notes here. Factoring, we've written this before, but we'll write it again because it's important. Factoring and expanding are inverse processes. They're opposites of one another. So we're going to use this whole idea to try to factor trinomials. And it's going to be a bit tricky. There's a process we can follow. There's several ways to do them, but I'm going to recommend one method, and hopefully you pick it up because that's kind of the most common method. So at first it's going to be really strange, and then you guys should have no troubles at all with it. So moving down here, we've used the letter V here as a variable. It doesn't matter. This could be an X, so don't get kind of caught off guard by the fact that it's the letter V. I know you guys are pretty good with that, but every once in a while somebody kind of says, oh, V, I've never seen a V before. So x squared plus 12x plus 20. This is a trinomial that we're going to attempt to factor. So the method here that is shown in the yellow algebra tiles is factoring with algebra tiles. So this is a method you can use. So what we've done here is we have a v squared, and then how many v's do we have? Well, we have 12. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 11 and 12. So there's v squared, 12 v's, and then we have 20 of these little blocks. So there are 20 of them there. So what we've done here is we've represented v squared plus 12v plus 20 as a bunch of algebra tiles. Now, in order for this to work, in order to be able to factor using algebra tiles, you must make a nice rectangle. You can't be missing any pieces of your rectangle, else it doesn't work. So this is how we can do it using algebra tiles. And remember when we did it up at the very top, we said, okay, we had c plus 3 and c plus 5, and we multiplied them together, and we ended up with this rectangle, which was c squared plus 8c plus 15. We ended up with the rectangle. Now what we're doing is we're going to take that rectangle, and we're going to work backwards. So if I have a rectangle with all these pieces in the middle, what do I have across the top, and what do I have across the side? So if I go back to my example here, here's my big rectangle, and what do I have? Well, I have a v squared right here. I have I have 10 v's here. And then what do I have down here? I guess this is v squared, or v. If I just think of the length from here to here is v. And then I have 1, 2, 3, and all the way across here, I have v plus 10 blocks. And then what do I have down this side? Again, I have v, that's the length here. And what do I have here? I have plus 2. So if I were to multiply these things together, I would have ended up with this, sorry, plus sign there, a big rectangle that looks like that. So that is kind of where or how you can use algebra tiles to factor. So we say that the factors of v squared plus 12v plus 20 are v plus 2 and v plus 10. If we went backwards and we multiplied the v plus 2 and v plus 10 out, we would end up with v squared plus 12v plus 20. So this is kind of the trick that happens when we factor something. We always see that we end up with this last term. So 20 is the product of 2 and 10, and then 12 in the middle here is the sum of 2 and 10. And that is the trick we're going to use. It's really confusing. Once you do a few examples, it gets a lot easier though. Remember, we're just learning how to do this for the very first time right now. And I promise you it'll get easier. So factoring a trinomial of the form x squared plus bx plus c. My box kind of got broken up here. So the constant term is the two binomial factors are the two numbers whose sum is, so we always want to add to the middle term, so sum is b, and that's referring to the b from up above there, and then their product is c. And I apologize for that being on two separate pages. So the process is the same every time, and we're going to do a bunch of examples. And in the course, I've actually added a few extra examples for you guys to go through because this is such an important idea in terms of you being able to do it. And it's kind of one of these light bulb ideas where you'll go through it a few times and be like, I don't get it. And then all of a sudden it'll just be like, click, switch flips on, and you just understand how to do it. So the idea behind factoring is finding two integers whose sum is -2, that was our middle term, and the product is -8, because that was our last term. If I want to multiply, because I'm talking about product, multiply something to -8, what has to happen with my terms if I'm multiplying to a negative value? In terms of signs, my two terms can't have the same sign and end up giving me a negative. If I had a positive times a positive, I would end up with a positive. If I have a negative and a negative, I end up with a positive. So if I have a number, I have to figure out something that multiplies to -8 and adds to -2, the numbers have to have different signs because it's -8. It can't be two negatives, it can't be two positives. It has to be one negative and one positive. So the two factors must have different signs because the 8 is negative in this example. All right, so numbers that multiply to -8. What are numbers that multiply to -8? They must have different signs. So I can take -1 times +8. Those multiply to give me -8. I can take positive 1 and negative 8. That'll work too. I can take negative 2 times positive 4. I can take positive 2 times negative 4. Those will multiply to give me negative 8 as well. 1 and 8, 2 and 4. Is there anything else that multiplies to give me negative 8? You can think of? No, I can't think of anything. So what we set up above is we need two numbers who multiply to give us negative 8, but they must add together to give me negative 2. So if I took negative 1 plus 8, what does that give me? Well, that gives me 7. Is 7 the same thing as negative 2? Nope. So that's not the one I want. If I took positive 1 plus negative 8, what do I end up with? Well, that gives me negative 7. So that's not the one I want. How about negative 2 and then add 4 to it? What do I end up with? I end up with positive 2. I don't want that. So it must be the last one here. 2 plus negative 4 gives me negative 2. And that is what I wanted. In the original question, I said I wanted them to multiply to negative 8 and add to negative 2. And Alex, you're right. With three numbers, you can multiply them together, but we only want to deal with two numbers here. And I'll show you why that is here in a second. So if I take my original question, x squared minus 2x minus 8. What I want to do is I want to break my middle term up using the two factors I just chose. So I have x squared. I have the factor I chose were 2 and negative 4. So I'm going to break this negative 2 into positive 2x and negative 4x, and then minus 8. So I'm just splitting my middle term up into two terms. It still is going to add to the same thing. I'm just trying to work backwards, essentially. Now what I'm going to do is I'm going to look at my terms a little bit separately. So I have the first set of terms, and then I have the second set of terms. What's common to my first terms in the green there? What's shared between those two things? Well, this one has an x squared, and this one has 1x. So I have an x I can pull out of each of them. This is factoring. If I pulled out an x, what am I left with? Well, I'm left with an x and a 2, because x times x is x squared. X times 2 is 2x. How about my second two terms? What is common to those two terms? This is in red now. I have a negative 4 and a negative 8. What's going to be common to those? I'm going to pull out a negative 4. And that's going to leave me an x and plus a 2. Because negative 4 times x is negative 4x. Negative 4 times positive 2 is negative 8. The sign isn't super important right now. The key here is everything in my brackets is the same. And that's what you want to end up with. So everything in the brackets is the same. I have an x plus 2 there. I have an x plus 2 in both terms. So what I'm going to do is I'm going to pull out my x plus 2. And I'm going to be left with x and minus 4. Now, I'm confident that I've lost nearly all of you with that explanation, and that is okay. Because the very first time you've seen it, this stuff is not easy, and there's a few steps along the way and a couple tricks you're going to run into. So it's okay to not understand right now. We're going to do a bunch of examples, and I'll do a few more with you guys. And hopefully by the end of the block, these things start to kind of click a little bit for you. So that is a way to do all of these questions. If you follow that exact process, it'll work every single time. Now, you've only seen the process once, so you probably, if you kind of caught on to this stuff over here on this behind me where you just have, the factors that multiply and add to, if you can get that far, that's good. If you can just get to the next step each time you see a new problem, then you're doing okay. What does this really mean? I've got these two things, x plus 2 and x minus 4. Why do I have this? What did I end up with? Why do I care? Why am I here with these two sort of binomials? Now, the idea here is we were asked to factor at the beginning. So what we've done is said, okay, if I start with something like x squared minus 2x minus 8, can I break it down into two smaller things that multiply together to give me those? So the final answer is this. If somebody said factor x squared minus 2x minus 8, and you said, oh, x plus 2, x minus 4, those are the factors of that, that would be the answer. So in the box, that's the answer. Okay. What we can always do with these types of questions, as I showed you guys last day, is check. That wasn't very good. So when I say check, what do I mean? I mean FOIL my answer. So if I had x plus 2 and x minus 4, if I FOIL, I go x times x is x squared, x times 4 is negative 4x, positive 2x, negative 8. I combine my like terms in the middle, x squared minus 2x minus 8 for my x. Is that what I started with? It sure is. So I know I have the right factors. So a lot there, I totally understand. Let's look at another example. When we factor a trinomial, we always ask, I need two terms that multiply to the last number and add to my middle number. So if I need two terms that multiply to give me 35, and in this case is positive 35, I need to think of all the numbers that I can multiply together that give me 35. So I'm just going to write it out actually. We need numbers that multiply to 35, but add to our middle term, this negative 12. Multiply to 35, add to 12. In this case, negative 12. All right, so let's start with 35. What are numbers that multiply to 35? So 35, think about it. I always have 1 and 35, and I could have negative 1 times negative 35. Those both multiply to give me 35. What other numbers do I have? Avery asked a great question. Would there ever be a time when the method for finding the sum, like multiplying and sum, it just doesn't work? Yes. If that happens, it can't be factored. Some things can't be factored. That's just okay. You're going to end up with that. So if there are no numbers that multiply the last term, add to the middle term, it can't be factored. If you think about it this way, if I can't take all of those algebra tiles and make a rectangle with it, if they don't all fit nicely in here, and I end up with like a gap here once I've filled everything in, this gap means that it can't be factored. And that happens sometimes. Some things are unfactorable. It's like taking like a prime number, like 7. I guess I can always factor it into 1 times itself, but 7 is factored as far as it can go. There's nothing you can do to a 7 other than 7 and 1 to factor it any further. I can't take the 7 and factor it any further. It's just, it's prime, it's factored. So sometimes you'll start with a question that's actually prime, and that's as far as you can go, even though there's variables in there. So it's gonna happen. Alex and Abby have run ahead of me in chat here, and they've got all the answers written down there, so I'm just gonna kind of catch up to them. I can take 7 and multiply it by 5, and that should give me 35. And I can take -7 and multiply it by -5, and that'll give me 35 as well. Those are all of the factors of 35. Those are the only numbers, when we only consider 2 numbers being multiplied by one another, that will end up giving us 35. We have 1, 35, 7, and 5. There's nothing else. So because it's positive 35, we can have negative as well. So now I want to think about all these numbers that multiply to 35, but they need to add to -12. So if I take 1 and I add to it 35, that gives me 6. That's not what I want. -1, I understand most of you have already sorted this out, but I'm just going to write it down, is -36. 7 plus 5 is 12, which is looking good, but it has to be -12, which is -7 and -5, which gives me -12, which is the one I was looking for. Wowzers. So these ones I didn't like, but I like this one. So the factors I'm looking for are -7 and -5. I said 1 and 35 gives me 36. Yeah, you're right, Alex. 1 and 35 is 36. All right, so I'm going to do it the long way again. Yeah, I'll do it the long way again. So what I do is I start with my question. X squared minus 12x plus 35. That was what I started with. I said that this -12 term, I can break into which 2 numbers? Which ones did I pick? Well, I picked this -7 and -5. So I'm going to break -12x into -7 and -5. So I have x squared, -7x minus 7x minus 5x plus 35. Does it matter which order the 7 and the 5 get written in? No, it does not. You can write them whatever order you want. If I wanted to write it as minus 5x minus 7x, that would be fine. I didn't, and I want you guys to have the same thing as me, so I'll switch it back. So x squared minus 7x minus 5x plus 35. So all I've done is I've taken my middle term, my 12, and I've broken it into 7 and 5 because I want to factor this thing. Now this is kind of where it gets a little abstract, I guess. We want to look at the first 2 terms, and then we want to look at the second 2 terms, and we want to say, is there anything common to these? So the first 2 terms in red, what is common to x squared and 7x? What is the same in each of those terms? Well, each of those terms contains an x. If I pull out an x, what am I left with? Well, I'm left with 1x and a minus 7. Because x times x, if I multiply this out, is x squared. X times -7 is -7x. Perfect. The next term. What is common to those terms? In this case, it's green. I have a 5x and a 35. So I don't have an x shared between those things, but I can pull out a -5. If I pull out a -5, I'm left with an x. And this is kind of where it gets a little bit tricky. If I pull out a -5 from positive 35, what am I left with? Well, I will be left with -7. And you'll notice that the things inside the bracket here and here must be the same in order for this to work. So if I pulled out a positive 5, that would have left me a negative x and a positive 7. Now this thing in the bracket's different because it's negative x plus 7 and x minus 7. So those are different things. So I didn't want to do that. So I pulled out a negative 5. And I was left with an x minus 7, which was the same in the brackets. So both terms now, I have kind of two separate terms here still. If you want to, you could even just draw a line right down the middle. Both terms have this x minus 7 in them. So I'm going to pull out my x minus 7, and what's left? Well, I have an x from here, and I have a minus 5 from there. And that is my answer. X minus 7, x minus 5. Now, some of you that are kind of really with it may have noticed something along the way, and there is a little bit of a trick to these questions. I showed you a really long method because the questions we're going to do in a couple days are going to involve this method that we just showed you. So this method I used will work 100% of the time for all factoring questions that we do in grade 10. The trick was this: if you have the questions like we've had today, if I look back up here, I said my factors here were 2 and negative 4, and look what my answer was, x plus 2, x minus 4. Now if I go down to the next question here, I said my factors were negative 7 and negative 5. What were my answer was x minus 7, x minus 5. So there's a bit of a trick we can use here with really simple trinomials like we've been dealing with, that we can actually end up just, once we figure out the factors, we can just use those as our solution. So let's look at another example and just see if we can use that little trick to make it work. All right, so factoring a trinomial, this one looks a little bit different, and the only reason it's any different is because the first term isn't our squared term. So it's just written backwards. So let's just rearrange it. And we say write in descending order, meaning the highest exponent first and then lower from there. So instead of writing it as negative 24 minus 5d plus d squared, I'm going to write it as d squared minus 5d minus 24. So I've just rearranged my terms. And this is going to make it easier to figure out what I need to do here. So I need numbers that multiply to negative 24 and add to my middle term negative 5. So let's start with our factors of negative 24. So I'm going to write down negative 24 and I'm going to say, what numbers can I multiply to give me negative 24? This one's a little trickier because there's a lot of numbers that give me 24. So I'm just going to start with things like 1 and 24. I could have, what else do I have? 24 is 6 and 4. So 6 and 4. One of these always has to be negative. 24 can be 8 and 3. And I can just keep writing the factors, flipping the negatives around, but it kind of doesn't make sense to write them all down because we know they have to add to negative 5. So if I know where I need to end up, I can just say, well, I don't need to write down all the factors because if I add negative 1 times 24, that's not going to add together to give me negative 5. I'm thinking 6 and 4s are always going to be like 2s, negative 2, but this negative 8 and 3, that's looking really good. If I take negative 8 plus 3, that's going to give me negative 5. So that is the factor that I'm interested in. Now, from the last two examples, I made a bit of an observation. Whatever we end up with inside in terms of our two factors in our little circle here, whatever we end up with there, those are our solutions. So let's just kind of maybe take the lazy way out here and see if this works. So I'm going to say, okay, well, the last two examples I had d and whatever I had as my factors was my solution. So d minus 8 would be one factor and d plus 3. Those were my two factors. I take my negative 8 from here, I take my 3 and kind of plug them in there. Now, because we took a bit of a shortcut here, we should always check to make sure that these were the right answers. So if I take d minus 8 and I take d plus 3 and I multiply them together, I get d times d, which gives me d squared. I get d times 3 is 3d. Negative 8 times d is negative 8d. And negative 8 times 3 gives me negative 24. Combine my like terms in the middle. I have d squared minus 5d minus 24. Is that what I started with? That is in fact what I started with. So if you wanted to write like a final solution like this, d squared minus 5d minus 24 is what you started with. And you're saying if I multiply d minus 8 by d plus 3, I'm going to end up with the same thing I started with. So those are equivalent. So that's a bit of a quicker way of doing these types of questions. Let's look at one more and then I'll give you guys a little bit of time to work and I can maybe answer a few questions for you. Are we feeling a little bit better there? Taylor thought she got it on the last question. How are we doing now? Is that better? Are we getting there? Or are we still kind of out in left field? Not sure. Silence. Okay. Factoring a trinomial with a common factor. Anna's getting there. That's good. So this question's only tricky because all of the terms so far we've had nothing in front of our x squared term. So now all of a sudden we have a negative 4 here, and this changes everything. It doesn't really change everything. It just says, okay, we have a number in front of our squared term. In this case, it's t. We still need to always remember, and this is true for just about all of the things we do in math, can we simplify it before we actually do the problem? So this is what we're going to write down here. Remember, to look for common factors. I guess we could go in all terms. Is there anything that's shared by all of the terms? So in the case we have here, we have negative 4, negative 16, positive 128. Now, these are always going to work out for you guys, so you should recognize that there's something common. So in this question here, negative 4 is common to all terms. So I'm going to factor it out. I'm going to say, okay, I'm going to take my negative 4t squared minus 16t plus 128. I'm going to pull out a negative 4. So if I have negative 4 times t squared and I pull out a negative 4, I'm just left with t squared. And then I have negative 4 and 16t. If I divide all of these terms by negative 4, what do I end up with? Well, I should end up with positive 4t. And then 128, if I divide that by 4, I'm going to end up with negative 32. So I've taken a 4 out of all 3 of my terms. Now,